Hey guys, welcome back. So today we're looking at 8.5 Training Day Part 2. So let's go ahead and jump right in. So in this first part, we're looking at describing the spread. So we've got a few different ways to represent data. So in this first one, it's a histogram. The second one, it's a line plot. And the third one, it's a box and whisker plot. So different ways to take and describe the spread of data is to look at its range, decide whether or not it's symmetrical, state any extremes it might have or any outliers, that sort of thing. So the spread of this data, we're going from 60 all the way to 90. So we have a spread of 30, or sorry, not a spread, a range. Our range is 30 because that's from high end to low end. Now, it's somewhat symmetrical, so notice it's low, then it jumps up, then it comes back down, so it's somewhat symmetrical. And the extremes are 60 and 90. Now here we've got a line plot and also a box and whisker plot. So we're going to look at the box and whisker plot. So we've got a range from 50 to 400. So 400 minus 50 is 350, so its range is 350. There are no outliers. The interquartile range, so that's this right here, because we have this split into different quarters, is at 200. So interquartile range, 200. And the extremes are 50 and 400. So you guys will do the line plot. So look at the data, see what the range is, whether or not it's extreme, what the extremes are, if there's any outliers, things like that. All right, so our next section is looking at translation form. So we looked a little bit at this last time. Now we don't have the graphs. Now we just have the equations, or a table and an equation. So you are given information about f of x and g of x. Rewrite g of x in translation form. G of x equals f of x plus k. Translation form is your keyword for this lesson. So f of x is 7x plus 13. G of x is 7x minus 5. How do we go from 13 down to negative 5? Well, we subtract 18. So it's f of x minus 18. So we could add or we could subtract. It just depends on which direction we're going. So if our g of x is negative and our f of x is positive, we're subtracting. If it's the other way around, if it's negative f of x and a positive g of x, we're adding. Now, on the tables, it's definitely a little harder to see, but here at 3, we have f of x is 11, g of x is 26. What do you do to 11 to get to 26? We add 15. What do you do to 46 to get to 61? You add 15, so on and so forth. So it's g of x equals f of x plus 15. So you're just comparing these two columns in the table. So how do you get from 5 down to negative 42? You subtract 47. How do you get from negative 1 to negative 48? You subtract 47. How do you get from negative 13 down to negative 60? You subtract 47. So our translation form will be g of x equals f of x minus 47. All right, and last but not least, vertical and horizontal translations. Use the graph of f of x equals 3x to do the following. Sketch the graph of g of x equals 3x minus 2 on the same grid. So let's see, bump that up a little bit. So we're at minus 2, but we have the same slope. So up 1, 2, 3 over 1, up 1, 2, 3 over 1, 1, 2, 3 over 1. So this purple line here is our g of x. Obviously, my line is not very straight at all, but you get the idea. Now for b, it says sketch the graph of h of x equals 3 times x minus 2. So what this does is it's going to shift it to the right. So we're going to start over here, 2, and then we go up 1, 2, 3 over 1. 1, 2, 3 over 1. Down 1, 2, 3 over 1. Down 3 over 1. So it changes the equation. So instead of a vertical translation, now we have a horizontal translation. But all three lines are still parallel. Obviously, they don't look it because of how wavy my lines are, but same idea. So you guys will answer C and D, explaining how f of x, g of x, and h of x are different and alike, and then how the parentheses affected the graph, okay? All right, if you guys have any questions, feel free to ask. Have a wonderful day.